Hi everyone. Today we are going to see about the new chapter sequences. So sequences. Before we start the chapter, let me discuss about the use of our of the sequences in our real life. So it is it can be seen throughout our flowers like sunflower. See, the sunflower has buds in the center, which is having a which is being formed with the Fibonacci sequences. So the Fibonacci sequence is the famous, so which is found by the person named Fibonacci. So we can see the sequence, different sequences, also in the wings of the insects. So what is the sequence? Sequence is a set of numbers which are arranged in a certain pattern. So when it is certainly written in a pattern of numbers, that is called a sequence. For example, you can see the number 3, 6, 9, 12, and 50. So it is written in a sequence. How do you say that? I just write 3, 6, 9, 12. I'm just going to verify it now. See, 3 plus 3 gives 6, and 6 plus 3 gives 9, and 9 plus 3 gives 12. So you can see that these are all the terms of the sequence. A particular number is called as a terms. Is called as a term. See, when you talk about one number separately, that is called as a term. Okay, so that is called a term of the sequence. So 3 is a term, 6 is a term, like that. We can point out the individual number as a term. We can see that the common difference between each term is 3. By adding 3 to each term, we can get the next term of the sequence. So, and then what are the consecutive terms of the sequence? So we are going to learn what is a consecutive term. See, this is a key term, keyword. That is, we can see the above sequence. In this above sequence, I can say that 3 and 6, 3 and 6 are consecutive terms. And also 6 and 9, you can see 6 and 9 are very close to each other. And I can say that 6 and 9 are consecutive terms of the sequence. And how to find out the term to term rule? There is a rule called the term to term rule. So for any sequence, we can find out the term to term rule. How is it possible to find out the term to term rule? You have to see what is the common difference between each and every sequence. That is the term to term rule. So in these terms, we can see that 3 is added constantly. It is an increasing sequence. So 3 is added constantly, and therefore a term to term rule is add 3. So that is the term to term rule. So next we are going to talk about the types of sequences. That is, there are two types of sequences. One is the infinite sequence, and the other is the finite sequence. So what is called infinite sequence? So infinite sequence means we can write the sequence terms as 2, 4, 6, 8, dot, dot, dot. If you can see 3 dots at the end of the term, at the end of the sequence, we can say that it is infinite sequence. So what does it mean, infinite sequence? It means that the numbers are uncountable and there is no end for the sequence of numbers. That is called infinite sequence, and therefore it ends with 3 dots. And what is called a finite sequence? It is a sequence which has countable number of terms, which can be countable easily. That is why we call it as finite. It has a limited number of terms. Now, for example, we can take the sequence 1, 2, 3, 4, and 5. This is also a set of, this is also a sequence of numbers. So since it doesn't have three dots at the end of the term, we can say that this is a finite sequence, and there is totally five terms in this sequence. That is 1, 2, 3, 4, and 5. So totally five terms in the sequence. That's why we call it as a finite sequence. We move to the exercise now. For each of these infinite sequences, write down the term-to-term rule. You can see the sequence given below: 2, 4, 6, and 8. How do we get this? By adding 2, by adding 2 to each and every term. We can see that uh, when you add 2 plus 2 you get 4, and 4 plus 2 you get 6, and 6 plus 2 you get 8. So like that. So the term-to-term rule is definitely add 2. The next two terms are, so 8 plus 2 is definitely 10, and 10 plus 2 is 12. So these are the next two terms. So we're going to find out the answer for the section B. We have the terms, the sequence of terms 1, 4, 7, and 10. So how to find out the common difference for the sequence? There's another method. We can find out the common difference. The common difference is usually denoted by D is equal to term 2 minus term 1. So we have to take the consecutive terms, and we will take it as term 1 and term 2 and subtract it. So we get the common difference. So here is term 2 is 2, 4, and the term 1 is 1. So 4 minus 1 is 3. So the common difference for the section B is 3. So we have to add 3 to each term, isn't it? So plus 3, plus 3, plus 3 like that. So for B, the answer is the term-to-term rule is add 3. Add 3. Okay. They'll ask you to find out the next two terms. The next two terms of this sequence are, see, 1 plus 3 is 4, 4 plus 3 is 7, 7 plus 3 is 10, and therefore 10 plus 3 is going to be 13, and 13 plus 3 will be 16. That's it. We move to the next question now. Write down the first three terms of each of these sequences. So the first term is given, and the term-to-term rule is given. So definitely the first term is 1, and the second term we have to add 5 with 1. So 1 plus 5 is 6, and 6 plus 5 is 11. These are the first three terms. For the next question, it is the first term 6, and 6 plus 8 is 14, and 14 plus 8 is 22. So this is the next question. It is about subtract. The term-to-term rule is subtract. It's different from add, so it's going to be a decreasing sequence. So 20 is the first term, and the next term is 20 minus 3, 17, and 17 minus 3 is 40. I hope you understood. We move to the third question. Copy these finite sequence and fill in the missing terms. So, as we said before, we have to make use of the formula common difference D is equal to T2 minus T1, term 2 minus term 1. 5 minus 2. So the second term is 5 and the first term is 2. So 5 minus 2 is equal to 3. So from that we got the common difference for each between each term. So 2 plus 3 is 5 and 5 plus 3 is going to be 8. 8 plus 3 is 11 and 11 plus 3 is 14. This is an increasing sequence. We are adding 3 between each terms. Next we go to the question B, 5, 11, 17. So this is also an increasing sequence. So for this 11, the difference is 11 minus 5. 11 minus 5 is 6. So we need to add 6 for each and every term. So 17 plus 6 is 23. And 23 plus 6 is 29. And 35 plus 6 is 41. Now we move to the next question, 26, 23. We find that this sequence is a decreasing sequence and therefore the common difference will be negative. 23 minus 26 is minus 3. 23 minus 26 is equal to minus 3. That is a common difference. That is a common difference for E. Let's see. For this question. See. So we need to keep on subtracting 3 for each and every term. 23 minus 3 is 20. And 20 minus 3 is 17. And 17 minus 3 is 14. So it is correct. Our answer is correct. We got 14 here. And 14 minus 3 is 11. So we got the answer for C. We move to D now. A simpler method, we get 90 and 82. We find this is also in a decreasing sequence. And yes, we will get the common difference negative. So 82 minus 90 is minus 8. You need to subtract 8 between each and every term. So when you subtract 82 with 8, we get 74. And 66 minus 8 is 58. And 58 minus 8 is 50. And finally, 50 minus 8 is 42. We move to the next question. We can find that there are two missing boxes, missing terms of the sequence. So to find these kind of terms, we need to see whether we have the consecutive terms, so that from there we can get the common difference. Here we have the terms 32 and 40 which are consecutive to each other. So 40 minus 32, 40 minus 32 is a common difference. D is equal to 40 minus 32. That is equal to 8. So here, it's an increasing sequence. We need to add 8 for each term. This is 16. 8 plus 8 is 16. And 24. And 48. And 56. So this is just an 8 tables. We move to the last question of question 3. So similarly, we find the consecutive terms, which is 28 and 23, which is decreasing. So we conclude that this sequence is a decreasing sequence, and we subtract 23 from 28, which will be negative number, which is equal to minus 5. And that is d is equal to minus 5. We need to subtract 23 with 5. 23 minus 5 is 18. And 18 minus 5 is 13. If you want to go beyond this number 28, we need to add 5. Then only you can get the exact number. That is, so now we're going to add 5. So the common difference is 5. To get the number before 28, we have to add 5 here. So 28 plus 5 is 33. And 33 plus 5 is 38. So 33 plus 5 is 38. So the sequence is 38, 33, 28, 23, 18, 13, and 8. Go to the next question. Write down whether each of these sequences is finite or infinite. Already we have learned the definition of the finite sequence and also the infinite sequence. So when we see the three dots in the end of the terms, we can say that that is a finite sequence, infinite sequence, and then if we don't see the three dots at the end of the sequence, then it is definitely finite. So for A, we can see the three dots at the end of the sequence, so it is infinite sequence. For infinite, just put capital I, and for finite, I'll just put F. For B, if we can't see three dots at the end of the sequence, so it is a finite sequence. The C is finite, and also D is infinite as it has three dots at the end of the sequence. Move to the next question. Okay. Copy this table. So it's given in the table. The first term is given, the sequence is given, and the term-to-term rule is there. We have to match the terms, sequence, and also term-to-term rule. The first term is 3. The first one is done for us, and the remaining we have to work out. So since the first term is, we can easily identify the first term as 3 over here. And see, 3 2s are 6, 6 2s are 12. So multiply by 2. So this is the answer. Okay. Next for 80, the first term is 8. So this is the sequence. So 80 by 2 is 40. 40 by 2 is 20. So divide by 2. So that is the answer. And for 17, the first term is 17. So this is the answer. And 17. So 17 minus 15 is 2. So subtract. So we get the answer here. And then for 1, 64. See, the first term is 1 here. And 1, 6, 31, 156. So multiply 5 and then add 1. So 1 into 5 is 5 plus 1 is 6. So that is that. Okay. So these are the sequences. Okay, we got the answers for all the questions. Move to the next one. Shane and Zalika are looking at the number sequence 4, 8, 20, 56, and 164. Uh, what Shane is saying, I think the term to term rule is add 4. Let me check first. So add 4. Now first sequence is 4. First sequence is 4. When you add 4, you get 4 plus 4 is 8, and 8 plus 4 is 12, and 12 plus 4 is 16. Whereas the given sequence is different from the term to term rule of Shen. So this is not possible. And when we check with Zaliha, what she says, the term to term is multiplied 2. So 4 is the first term, and 4 into 2 is 8, and 8 into 2 is 16, and 16 into 2 is 32, which is also not available in the sequence. It is also not available in the given sequence. So both of them are wrong. So either of them are not correct. So you can say both of them are wrong. As their term to term rule doesn't match the given sequence. We move to the next question. Riker is trying to solve this problem. Work out the answer to the problem, explain how you solve it. The second term of the sequence is 13. The term to term rule is multiply by 2, then subtract 3. Multiply by 2, and then subtract by 3. What is the first term of the sequence? To find the first term of the sequence, to find the first term we do the reverse of the above operation. Of the above operation. That is, they have mentioned that first they multiply by 2 and then subtract by 2. So we go to the reverse. So what we need to do is, so we are going to add 3 first with 13. With the number 13, we are going to add 3. So 13 plus 3 is equal to 16. And after adding, since it is multiplication, we are going to, the opposite of multiplication is division. So 16 divided by 2. Since they multiply by 2, I am dividing by 2. So 8. So these are the first step and the second step. First step we add with 3 because they have subtracted 3, we add here, and because they have multiplied by 2, we divide by 2. Finally, we get the number 8, which is the first term. This is the first term. Thank you.